So I'm going to be going over some of the problems that you have been working on, and then some that you're not at yet, but will be pretty soon. So since we won't be meeting tomorrow, try to give you like a head start on that so that you hopefully by the time you get to them, it's not as bad as it could be. So let's get started. So first, these two first ones are from the current unit section that you're on. So we want to find the sum. So let's write down, you should hopefully be seeing my paper and the problem. So let's write down the first one. So for this first ones, we're adding them. So when we're adding them, I recommend that you write them vertically, just like we do with numbers. So for example, we have the number 5, 2, 7, 5, some random number. How would we add these? Well, we would write them vertically, so one over the other, and it just makes addition much easier to do because then you're carrying over to the next value and so on. So similar to that, let me see if it's too dark. But in this case, we're using polynomials. So here then we have 8x squared minus 9y squared minus 4x. We're adding x squared minus 3y squared minus 7x. So when we are placing them vertically, make sure that the variables with the corresponding exponents are above each other. So x squared, y squared, and x. Just makes it much easier. So now we add. You could either start from the right or start from the left. In this case, I like working from the left to the right. And it just keeps it like everything else that we do, how I've been telling you guys, you read from left to right. So I like to do it that way. So here, x squared, 8x squared plus x squared. Remember that that's 1x squared. So in total now we have 9x squared. Negative 9y squared plus negative 3y squared. So they're both negatives. We keep the sign. We add the values. So negative 12y squared. Here, negative 4x plus negative 7x. They're both negative. We keep the negative. We add the values. So 7 plus 4, 11x. So that's for addition. Now, when we have subtraction, one of the things you have to be careful with is that negative sign outside of the parentheses. So for the first polynomial, we have 15x squared plus 11y squared plus 8x minus the second polynomial, 7x squared plus 5y squared plus 2x. So in this case, when we have subtraction, your first step is always to distribute that negative. So the first polynomial will stay as is, but the second polynomial, we need to distribute that negative. So now it becomes 7x squared, negative 7x squared, negative 5y squared, and negative 2x. So everything gets multiplied by that negative, and then our problem becomes an addition problem. So as long as we know how to add, then just like the previous problem, we're fine. But first, distribute the negative, and then your problem becomes an addition problem. If you have any questions, please feel free to unmute yourself along the way. And if my screen stops sharing, let me know. But now that we have an addition problem, it's just similar to the one that we previously did. So we can write them vertically. So we have 15x squared plus 11y squared plus 8x. We're adding negative 7x. Oh, I forgot the squared there. Squared minus 5y squared minus 2x. And then we just work with each one of the variables. So here, 15x squared plus negative 7x squared. Well, that 15 is positive, the 7 is negative, so positive and a negative we're subtracting, and we keep the value of the bigger one, so 8x squared. 11y squared minus 5x squared, that's positive 6y squared, and 8x minus 2x, positive 6x. So that's just the only thing with this first section that you're on, is that when we are adding, I strongly recommend write down the problems, and when you're writing the polynomials, write them vertically so that it's one polynomial over the other, and then you're just adding. And also being careful that you can only add when they have the same variable, but also they have to have the same exponent. So here, x squared, that's why it works, y squared, and x. In the second one, when we're subtracting, the first thing that you need to do is distribute the negative. Once you distribute the negative, your problem then becomes addition. So then it's what we've been doing with the addition ones. So just keeping that in mind as you're working in this first section with addition and subtraction. Okay, any questions so far?
No, makes sense.
Okay. So let's go on then to, so we did 1 and 2, so now we're on to number 3. Zoom in on. All right, so with number 3 then, we have here, we are wondering which one of the laws we are using. So one of the important things with this section is that make sure that you write down all of the laws and all of the that regarding exponents and multiplying and dividing. So make sure within your notes, and I think it's within the packet, so it shouldn't be, it's important that you have them, and that I would also write down an example for each one of them, just so that when you're going back onto it from the test or from anything that you're working on, they're there for you as a reference. So make sure that you write them. But in this case, we can narrow it down. What operation are we doing? If we look at here, we have 3 to the power of 10 divided by 3 to the power of 4. The fact that we're dividing, that's a quotient. So that lets us narrow it down to these two options. It's now just being very particular of how do we say it. It's product, it's a quotient of powers. Quotient because we're dividing, and powers because we're using rules for exponents. So it's just being very, like, again, it's something that just make sure that you write down and that you have it for your test and for your quizzes. Quotient of powers. So how does this work, the quotient of powers law? It tells us that as long as our exponents have the same base, so in this case our base is 3, then we can, if we are dividing for a quotient, we can subtract the exponents. So in this case, for our answer then, since both of them have a base of 3, we keep the base, and for our exponent, we subtract. So it's 10 minus 4. So this is 3 to the 6th power. That's our answer. Okay, well, is that true then? Let's check. 3 to the 10th power, that is 10 threes being multiplied. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 to the 10th, that is 10 threes being multiplied. Now 3 to the 4th, that is 4 threes being multiplied. So 1, 2, 3, 4. Now, when we reduce this, when we simplify this, 3 divides 3 once, so that's 1. 3 divides 3 once, that's another 1. 3 divides 3 once, and 3 divides 3 once. What are we left with? We're left with 1, 2, 3, 4, 5, 6 threes. So it's 3 to the 6th power, and it works that way. So just keeping that in mind, let's say that it would have been, for example, if the problem would have been written as 3 to the 4th divided by 3 to the 10th. In this case, because you want to look at which exponent is the greatest, the 10 is the greatest. So it would be 1 over 3 to the power of 10 minus 4. So 1 over 3 to the 6th. So in order to determine if it's going to be in the denominator, or in this case it's in the numerator, you have to look at where is the greatest exponent located. Is it in the numerator or is it in the denominator? In this case, since it's in the numerator, it goes up to the top, making it a whole number. But in this one, because the greatest exponent, the 10, is in the denominator, it stays as a fraction over 1. Okay? Any questions with that?
No.
No? Okay. So let me know though. But yeah, just being very particular about making sure you know the laws and how to use them. So this is for the next unit that's coming up, similar to this one. Let's do this one. So number 4, we have a to the 8th times a to the 4th. What this tells us is that there is 4 a to the 8ths being multiplied. When we multiply, as long as we have the same base, what we're doing then is that we add the exponents. A 8 plus 8 plus 8 plus 8, which is the same as a 8 times the 4, because there's 4 8s that are being multiplied, making it a to the 32nd power. So the power to power rule, if I remember correctly, tells you that we can take the exponents and multiply them, which is what we did here. So just knowing where that comes from is that this is telling us there's 4 a to the 8ths. When we add the exponents, it's the same as multiplying 8 times 4. So it works either way. If you happen to forget these rules, just use what you know about exponents and you'll get the same answer. Okay?
Okay.
This one's similar to the one we just did, number 5. So number 5. Number 5. R to the 9th divided by R to the 3. So using the quotient of power rules, they have the same base, R. 9 is in the numerator, so that's where it would be. I could put a 1 underneath it if that helps us to visually see what's going on. So it's 9 minus the 3. 9 minus the 3, that's R to the 6th over 1. Anything over 1, it's just the number itself. So R to the 6th. Okay. And let's say we forget the rule. It's okay. We have 9 R's being multiplied. Divided by 3 R's being multiplied. When we reduce, that's 1, that's 1, that's 1. We're left with 1, 2, 3, 4, 5, 6, 6 R's. So R to the 6th. And the denominator is just 1. So either way, I mean, it makes your life much easier if you remember the rules, so that's why we want to make sure that you're familiar with them. But if you don't panic if you forget them, but just make sure have them in your notes and all that stuff.
Okay.
Now, when we multiply, one of the things that I would recommend for you is to use tables. I like to use tables when I multiply polynomials, especially when they get much larger. This one isn't that bad, but let me show you how I like to do them. So let me write it down first. 4s plus 2 times 5s squared plus 10s plus 3. So, do you remember doing Punnett squares in biology?
Yeah.
Very similar to that. I like to write my polynomials when I multiply them that way, where we have a table. So up in the top across, it's going to be 5s squared, and each of the terms is going to have its own column. Okay, now across, we're going to be multiplying, kind of like what we did with Punnett squares where they come together. So now here we have 4s plus 2. Each of those terms gets its own row. So we have this so far. So we're going to end up with the square that's 3 by 2. So now, similar how I said to the Punnett squares, we come together. So we have 5s squared times 4s. We're not gonna solve for them yet. No, we're not gonna simplify yet. We're just gonna put them together. So now for this square, 10s times 4s. For this square, 3 times 4s. Okay? So similar how we did with Punnett squares. We come wherever the row and the column meet, that's where we know what to multiply. Here, 5s squared times 2. This one, 10s times 2. And this last one, 3 times 2. Any questions there so far?
No.
Okay. So now we're going to go back and simplify in each one of the boxes. So here, 5 times the 4, we have 20. S squared times s, that's s to the third power. Because remember, when we multiply, we add the exponents. All right, now this square here, 10 times the 4, we have 40. S times s, well, that's s to the first, s to the first, s squared. Now this square, 3 times the 4, 12, 12s. Any questions so far?
Nope.
Okay, let's go to this one then. 5s squared times 2. 5 times the 2 is 10, so 10s squared. 10s times 2, we have 20s, and 3 times the 2 is 6. Now what I like doing this is that afterwards, once we're done with simplifying, we're going to be adding diagonally. So for example here, 20s to the third is just going to be 20s to the third. That's our next term. Then the second term, we add diagonally. If we go diagonally, you will see in the pink that 10s squared plus 40s squared, they have the same variable, so we are combining like terms. So next is plus, not equal, plus 50s squared. Our third term, again, going on that diagonal, 20s plus 12s. They're both s. I add those up, 20s plus 12s. Next, our third term is 32s. And lastly, our fourth term, 6. It's by itself. So plus 6. That would be your answer. I like to do it this way. It keeps things neater. It prevents you from missing a term when you distribute, especially when things get a little messier. Sometimes you'll have a polynomial that's 3 terms, again, times another polynomial that has 3 terms. So it just makes things so much easier. Once you fill out, again, using what you know about Punnett squares, but you were multiplying, then you just go based on the diagonals, and then it helps you combine like terms.
Yeah, this is really similar to something I do anyways, actually.
Okay. Yeah, so sound good then? Any questions here?
Nope.
All right then. Let's go to this one then. So you see, once it gets a little messier like this, then you're like, okay, what do I do? So let's do, you want to work with 2 terms at a time. So let's write it down. 7x squared times 2x to the third plus 5 times x squared minus 4x minus 9. So in this case, let me try to get something. We're going to ignore that third term for now, and we're just going to work with these 2. So we have a monomial times a binomial. So this isn't that bad. So when we multiply here, let's distribute in this case. 7x squared times 2x squared. So 7 times the 2 is 14. For our variable, x squared times x to the third, that would be x to the fifth. Okay? Now, 7x squared times 5 plus 35, because 7 times the 5, 35x squared. Now, we have a problem very similar to the previous one. So whenever you have more than two terms, work two at a time, and then you'll end up with two terms at the end. It might take a while, but it's fine. So now we can go ahead and draw our table. So for our first one, let's do here x squared minus 4x minus 9. For our rows, 14x to the fifth and 35x squared. Positive 35x squared. Alright, so our numbers get a little large here, but it's okay. So again, filling in each of the squares. So for this first one, we have x squared times 14x to the fifth. Our second one, negative 4x times 14x to the fifth. Our third one, negative 9 times 14x to the fifth. Okay, now the second row, x squared times 35x squared, negative 4x times 35x squared, and negative 9 times 35x squared. All right, so now let's keep going. Now we go back and work within each one of the boxes. So this first one, x squared times 14x to the fifth, that's 14x to the seventh. Negative 4x times 14x to the fifth. Well, negative times a positive, that's a negative. And, oh no, let's bring up the calculator to help us out. It's loading. There we are. Did my screen freeze? Oh, there it is. So let's do 4 times the 14. 4 times the 14. 56. So negative 56 x to the sixth, since that's x to the first and x to the fifth, x to the sixth. Negative 9 times 14, that would be negative 126 x to the fifth. Now here, x squared times 35x squared, that's 35x to the fourth. Did I do that right? Yeah. Negative 4x squared times 35. So let's clear that. 4 times 35 equals 140. Negative times a positive, that's a negative, so negative 140. And it would be x to the third because 1 plus the 2, 3. Now our last one, negative 9 times 35. Negative times a positive is a negative, so negative 315x squared. Now, in this case, if we look at our diagonals, you will see that, let me highlight them for you. There's nothing that we can combine because here it's to the fourth, 6, 3, 5. So what we do is we write our terms in descending order based on the exponent. So our first term here, 14 x to the seventh. Next would be the 6 minus 56 x to the 6th. Next is 5 minus 126 x to the fifth, 4 plus 35 x to the fourth, minus 140 x to the third, and then minus 315 x squared. So whenever we cannot combine diagonal, we would just write the whole thing. Again, in descending order based on the exponents. That's how you determine which one comes first. Any questions with this one?
No.
Is there anywhere where I lost you or where it was confusing?
No, actually, I think I get it.
Okay. Again, you're not there yet in the lessons, but I just wanted to give you like a head start look at it so that when you do, if there's still some holes there, hopefully once you watch the lesson, it will all come together. So don't be overwhelmed if there's still some gaps there, because I'm trying to give you a head start, how I said. Sound good?
Sounds good.
Okay. Now, when we divide polynomials, when we divide, we want to use the same process that we use when we divide numbers themselves. So for example, if I'm dividing 762. Okay, if I'm dividing 30,762 by 6, I start with the number 3. 6 divides 3, 0 times. So I move on and I make it 30 now. 6 divides 30, 5 times. 5 times the 6 is 30. We subtract. 30 minus 30 is 0, and we bring down the next term. Now, 6 divides 7, 1 time. 1 times the 6 is 6. We subtract. 7 minus the 6 is 1, and we bring down the next term. Now, 6 divides 16, that would be twice because 3 would be 18, and that's too much. So 2 times the 6, 12. We subtract. 16 minus the 12 is 4. Bring down the next number, 2. 6 divides 42, 7 times. 7 times the 6, 42. Subtract. In this case, our remainder is 0. But I can rewrite this as 30,762 divided by 6 equals 5,127. Another way is 6 times our quotient, what we got at the end, is the 30,762. Just knowing that when we multiply them, we get what we started with. Okay, so here in this case then, when we're doing polynomials, we use the same process. So this is what we're dividing. So that goes inside of our little divisor here. So 3x to the 4th minus 4x squared plus 8x minus 1, and we're dividing by x minus 2. So we want to use long division. Later on in the units, you will learn synthetic division, you will learn other ways to divide, but for right now, we want to use long division. So it's the same process that we did when we're dividing numbers. So ignoring the minus 2, what do we need to multiply? And over here on this side, we only focus on that first term and ignore the rest. Focus on that first term and ignore the rest. What do we multiply x by to make it x to the 4th? Well, first we need to multiply it by 3x to the 4th. First we need to multiply it by 3. Then we multiply it by x to the 3rd. Because x to the 3rd times x, remember that's to the first power, that gets us that x to the 4th. 3 times 1x, well that's 3. So we get 3x to the 4th. Now we need to distribute. 3x to the third times negative 2. Well, positive times a negative. Remember, here we're multiplying. 3 times the 2 times the negative 2. Well, that's negative 6x to the third. So you see here how they're not the same, right? Because we need to add a placeholder for 0x to the third. So let me rewrite this for you. So our actual problem, even though they don't give it to us within the problem itself, is 3x to the fourth plus 0. We need to add that 0x to the third as a placeholder minus 4x squared plus 8x minus 1. So going back then, we said we need to multiply by 3x to the third, and then we got 3x to the fourth minus 6x to the third. So now ignore this part of it. This is our new problem now. This is what we need to continue dividing in order to solve. Like we did in the previous, when we were subtracting numbers, when we were dividing, we subtract. The operation that we do is that we're subtracting. So the operation that we need to do here is subtract as well. So these terms become the opposite. This one becomes a negative. This one becomes an addition. So now we're adding here. 3x to the fourth minus 3x to the fourth. Well, that's 0. Those cancel out. 0x to the third plus 6x to the third. We get 6x to the third. And we bring down the next one. Negative 4x squared. So just like what we were doing when we divide numbers. You subtract, you bring down the next number. You subtract, you bring down the next number. That's the pattern that we're going to follow. We subtract, we bring down the next term in this case. So now here, again, ignore that second term for now. Ignore the negative 2. What do we multiply x by in order to make it 6x to the third? Well, first we need to multiply it by 6. And to make it x to the third, we need to multiply it by x squared. So now we distribute. I'm going to move this. 6x squared times x. 6x to the third. 6x squared times negative 2. Negative 12x squared. Now, we make them the opposite since we're subtracting. So this is now a minus, and now this is addition. Because negative times a negative is addition, we're adding now. So here, 6x to the third minus 6x to the third, that is 0. Negative 4x squared plus 12x squared, that is a positive 8x squared. We bring down the next one. Add 8x. Again, ignore that. Ignore the negative 2. What do we multiply x by to make it 8x squared? Well, we need to multiply it first by 8. And then what do we multiply x by to make it x squared? We need to multiply by x. Because x times x is x squared. So now we distribute. 8x times x, 8x squared. 8x times negative 2, negative 16x. Now, we change their signs because we are subtracting. Here, 8x squared minus 8x squared, that is 0. So those cancel. 8x plus 16x, we now have 24x. We bring down the next one, the next term, so minus 1. Now, ignore the negative 1, ignore the negative 2. What do we multiply x to make it 24? We need to multiply by 24. 20, now we distribute. 24 times x, 24x. 24 times negative 2, negative 48. We change their signs. So negative, now that becomes a positive. 24x minus 24x, that's 0. -1 plus 48, or 48 minus 1, 47. This is your remainder. So your remainder, you write it over the divisor. So here, plus 27 over what we divided by. Well, we divided by x minus 2. So that's how we get that answer. Any questions with this one?
No. I'll
sure?
practice that as well when I get to it, but it makes sense.
Yeah, as long as you get the process for now. And again, this is like the last section in this unit. Just know that we're doing everything that we do regarding like the process, like how we divide numbers. We ignore everything else, start with the first term, bring down the next one. And it's the same procedure that we were doing when we divide numbers. So I just wanted you, again, it might be overwhelming right now, and I understand, so don't freak out on me. But I wanted to give you a look at it, so that way when you actually watch the video, hopefully it all comes together. I will also be posting these notes because I'm going to start recording myself. So you'll be able to look back at this. I'm going to post it in our Power Schools. So hopefully once you watch the lessons, once you come back to this, it will all make much more sense. Okay?
Okay.
All right.
Good thing.
So I am going to, give me a second. Let me stop.